you need to be able to read the instructions and determine what these segments are representing. I'm going to go ahead and kind of group them together. I see that I have 3 segments that are coming from the vertices to this point G. So I'm going to go ahead and outline these segments in blue. Then I see I have another set of 3 segments that are coming from point G and are perpendicular to these sides. You need to be able to read the instructions and interpret what is going on in this diagram. Because it kind of looks like these blue segments, kind of looks like those are angle bisectors, right? Kind of looks like that. It kind of looks like the red segments, they could be the perpendicular bisectors. It's the instructions that tell you exactly what's happening. Because these are not both the angle bisectors and perpendicular bisectors. That's not what's happening here. So let's read the instructions and see what happens. It says point G is the incenter. Point G is the incenter. When you read that on a quiz or a test, you need to think, what 3 segments create the incenter? So, what are the 3 segments that create the incenter? The angle bisectors. So you know that these blue segments are what? The angle bisectors, because they all meet at G. So I know that all these angles are being bisected. I know my blue segments, or at least I outlined in blue ink, those have to be the angle bisectors because they all meet at G, creating the incenter. So what's up with these perpendicular segments? What's up with these segments that I have outlined in red ink? Why even bother putting them in the diagram? What are they representing? What are those showing? It's showing the distance that the incenter is to all 3 sides. And when you have the distance of a point to an object, it's got to be the perpendicular distance. So what do I know to be true about these 3 segments? BG, DG, and FG. They're all congruent. Because I know that the incenter is equidistant from all 3 sides. So these perpendicular distances have to be the same. These are not your perpendicular bisectors. Point B, point D, point F are not your midpoints. You do not know that. These red segments that are perpendicular are just showing or just representing that perpendicular distance. So you need to be able to interpret and read your instructions and know what's going on in the diagram. You do not know those are the perpendicular bisectors. They're not. I'm telling you right now, they're not. So how do we solve this problem? It's asking for the length of segment BG. Well, segment BG is congruent to segment DG is congruent to segment FG. So if you find one of them, you got all 3. So what's the length of segment BG? 16. Okay? That one was easy because they gave you 16. But on problem number 14, you're going to have to use Pythagorean's theorem, and also on 15 and 16, you're going to have to use Pythagorean's theorem. Okay? That is all about angle bisectors. I told you in the past that these are the only 3 special segments that we're going to find equations of on next class's test. You're going to find the equations of altitudes, you're going to find the equations of medians, you're going to find the equations of perpendicular bisectors. You will not find the equations of angle bisectors. So this is what you need to know. This is what you can expect to be on the test about angle bisectors. We cool with that? Alright. Now we need to talk about your mid-segments. But if you look, since we're right here, please turn to page 94 and 95, since we're very, very close to it. This is all about your medians and your centroids. We've already learned this material, but this is just review for your test. This is review for your test. If you look up on the board over here to my right, your left, on page 94, you got 1 through 6 and 10 through 12. On page 94, you got 1 through 6 and 10 through 12. On page 95, you got all. On page 95, you got all. This is review for you about medians and the centroid. The last thing that we need to talk about and learn, pretty much, are your midsegments. So, if you have got room on the back of your points of concurrency chart, if you've got room, then that's where we're going to write it. We're going to draw another triangle about the same size as what's already there. If you don't have room on the back of your POC chart, point of concurrency chart, then you just need to get a blank piece of paper. The first thing we're going to do is draw a triangle. I'm going to make mine acute. So there's my triangle here. I'm going to go ahead and label this triangle A, B, and C. We need to know the midpoints of these sides because we're going to write the definition of midpoint. Or sorry, goodness, midsegment. Just by reading or hearing the name of this special object in triangles. What do you think this is? A line, a ray, a segment, a plane? What? Okay, obviously. It's a segment. Okay, how many endpoints does a segment have? 2. There's a clear beginning and a clear end. Well, the endpoints of midsegments, those are midpoints of triangle sides. So this is the definition of a midsegment. Midsegment is a segment that connects two midpoints of two triangle sides. It's just a segment that connects midpoints. It's just a segment that connects midpoints. So really quickly, I'm going to locate about-ish where my midpoints are. Just do it that quickly. It does not have to be perfect. Get a rough idea. You shouldn't be copying the board because you should have your own diagram right in front of you. Just quickly find your triangle's midpoints, and we're going to draw in these midsegments. The midsegment connects midpoints. So just connect midpoints. Those 3 segments that I just drew in, I'm going to label this midpoint M. I'm going to call this one N. I'm going to call this one P. Those segments in red ink are my midsegments. They are segments that connect midpoints. So if that's the case, I know a lot about this diagram. I know this segment's congruent to that segment. I know this segment's congruent to that segment. I know that segment's congruent to that segment because we're dealing with our midpoints. There is the mid-segment theorem. So go ahead and write this down. Mid-segment theorem. It tells us 2 things. The mid-segment theorem tells us 2 things. 1, a mid-segment is parallel to the third side. Now, what the heck do I mean by third side? Well, let's isolate one of these midsegments. In green ink, I'm going to go ahead and kind of outline that midsegment, segment MN. This is a midsegment. Well, the third side that they're referring to, that's the side that it's not connecting the midpoint of. So, the midsegment is parallel to that third side called AC. But if it's parallel to this whole side, then it's also going to be parallel to the parts. Right? It's also going to be parallel to the parts. And the second thing that this theorem tells us is that the midsegment is half the length of that third side. It's half the length of the side that it's parallel to. Midsegment is half the length of third side. It is half the length of the third side. So how many marks of congruency can I put on segment MN? 3. Because it's half of that third side. How many marks of congruency can I put on segment MP? 2. Because it's half of that third side. And how many marks of congruency can I put on PN? 1. So if I'm going to write an equation for this item 2, it would be something along the lines of the length of segment PN is equal to 1/2 the length of segment AB. This is an equation that you would write and use to help you solve problems. If you want to write another one, you can. How about the length of segment MP is equal to 1/2 the length of segment BC? The length of segment MP is equal to 1/2 length of BC. What's another way of interpreting this? The midsegment is 1/2 the length of the third side. Convey the same thing but different perspective. What's up, Rick?
The third side is twice as, or the length is twice as large as the midsegment.
Perfect. Another way of looking at this is saying, well, this third side, the length of segment AC, is double, is twice the length of segment MN. So if you don't like fractions, maybe you want to write that instead. Maybe you want to write that that third side is going to be twice the length of your midsegment. All right, guys, you can pack up and head out. Make sure your calculators are put away.